Yes, okay. Hello, everybody. Thanks very much for coming. Just a practical question before I start. Are there any of you who were at the yesterday's presentation of Ambrosus? Please raise your hands if you were. No? Okay. So it's just for our logistical purposes so that we know we can actually go through some of the parts we presented yesterday. So for those of you who don't know, Ambrosus is an open source project that enables any physical objects or smart devices to interface with distributed ledgers. And today we're going to have actually kind of a two-part presentation. The first part is going to be presented by me. I was supposed to be yesterday, but then the fire alarm came. So we're just going to do it like that today I'm going to start with a high-level overview and present you a couple of business use cases of how we bring IoT and blockchain together. And I'll use one particular example, which is going to be new. We haven't presented that before. And then Dr. Vlad Trifa, our Chief Product Officer, is going to take over and explain you how Ambrosus works under the hood, explaining you the architecture and so on. So just a short overview. We are, I would call us a scale-up. So we have around 60 team members worldwide, 120,000 plus strong communities. So that's token holders, as well as developers and participants in the network. We have more than 50 public partnerships and over 200 in the pipeline. And we're spread all over Europe, primarily Switzerland, Ireland, Estonia, and we're also based in Belize. We've won a number of awards. And in terms of what the three pillars in which we specialize are blockchain and IoT, as well as associated solutions built on top, which can be dApps, so actually smart contract powered applications, or they can be simply applications built on top of our architecture. In terms of the overview of the stack, just at a high level, so we work across different stacks, beginning with the core blockchain protocol. We have a layer of distributed storage around it. And then we have also various APIs and SDKs to permit easy development of applications on top of our blockchain and on top of our infrastructure. And we've created a bunch of different tools to enable entrepreneurs, startups, and IT enthusiasts worldwide to create to imagine and create new solutions at the intersection of IoT and blockchain. And in terms of how the different elements are interacting with each other, Vlad is going to give you a deep dive. But importantly, we're looking at the ways how physical objects and sensors can interact with blockchain. And in particular, before the data arrives to the blockchain where the data integrity is assured, how do you assure data integrity at the source? So we're working with edge gateways, which basically create data integrity at the source. They sign any readings from sensors, telling you the location, temperature, or any other parameters, and they verify, they put the data authenticity at the source. So what this means is that even if the data later on is transmitted to the blockchain through a centralized or insecure protocol, you still have data integrity at the device level. And now I'm going to walk you through a couple of industrial examples for how we've built solutions in the business sense. So I'm hopefully going to find the full screen mode is F5 normally. How do I make full screen? Sorry. Plan icon, I guess, right? Yes. So in terms of practical applications, so I'll show you how we did it for tobacco. So this is one of our latest use cases. And for those of you who have seen our booth, we have an exhibition booth near the main stages. You might have seen the RFID tags that we've shown, the chipless RFID tags. So that's one of the particular examples of the IoT innovations that we're doing. So Ambrosus is, half of us are from microelectronics and IoT backgrounds, and half of us are from the blockchain space and from software engineering. So we're always trying to see how we can combine two technologies to create valuable solutions for businesses. And the example for tobacco is related to the current regulatory developments in Europe in particular, where, for instance, every single pack of cigarettes has to have a unique ID starting from next year for the purposes of traceability, as well as fighting the counterfeiting and rerouting of tobacco products to different markets. You also have, by the way, similar regulations in the pharmaceutical space, and we're also working in the pharmaceutical space, where every single prescription medicine sold in Europe has to have a unique ID. And the question then becomes, how do you tag an object And current techniques to do that are pretty expensive. I mean, the cheapest ones are still around 8 to 10 cents, which if you're talking about a pack of cigarettes or maybe cheap consumer medicine, even that is a significant cost factor for companies. So we've created a chipless stack, which basically contains a unique ID. There are up to 18 quintillion combinations, so it can create a bunch of different products. And at the same time, it doesn't have the chip inside of the RFID tag, because the RFID tag doesn't need to store any data at the chip level. Instead, the data is relayed to our blockchain and to our distributed storage immediately. So we found clever ways to significantly reduce costs for the producers. So this particular chipless tag at scale, it costs only 1 cent per unit, which is significant because right now it's about 10 cents. So it's basically we're taking an order of magnitude in terms of costs away from the tobacco producers, and we enable them to tag the object. And once the object is tagged, what happens at Ambrosus is that the moment you produce a new pack of cigarettes, you give it a unique ID, you also create an asset on our blockchain. And Vlad will explain you exactly how assets and events work, but basically an asset is a digital representation of a real-life object on the blockchain. And then the moment you've tagged it, you have this ID. And then what happens is that the pack of cigarettes or maybe the pack of medicine is traveling through the supply chain, and it changes hands. There are different conditions of storage, temperature perhaps, exposure to light, humidity, any parameters that can influence the quality of the product. You can actually record this information, linking it to a particular tag, linking it to a particular ID of the object, and record it safely on the blockchain. So this is, and from that, what you can do traceability, you can do quality assurance, you can assure the authenticity of the product. So it immediately starts solving a lot of the global problems in trade, specifically in Europe, since we're now in Europe. There are a number of legislations at the EU level in terms of global trade where exporters have to prove the origin of their products and prove the quality of their products. So with this, you actually have a solution where you take the IoT element and the unique tagging techniques and combine it with a blockchain solution. The important question will be there, of course, well, you're talking about millions or billions of units and billions of IoT devices. And first question is, how do you assure security of the data? And again, you're very welcome to welcome our booth where we can show you the devices we have, which put this cryptographic signature to sensor readings. But the second basic question is, how do you scale? And in terms of scalability, we also have a solution that permits you to cover the entire supply chain. And we do it by bundling transactions together. So a bundle, again, is a concept that was created within Ambrosus, whereby it's basically a layer 2 scalability through which you essentially, instead of a transaction on the blockchain itself, you put a bundle of 16,000 entries, which can be assets or events, and you store them actually in distributed storage. So it's an IPFS-like environment around our blockchain, and it stores the bulk of the data, or the companies can even store it themselves if they don't want to make the data public, and you only put the metadata and the hashes on the public network. So companies don't have to reveal their whole supply chain and how it works and what commercial relationships they have. So for many companies, that's a big concern. But at the same time, they can prove the authenticity of data and that the data itself hasn't been changed. So if later on, either the government or business partners or the end consumers for tobacco products or for medical products and so on, if later on they actually want to verify the data and compare it with the original, they can always do that. Of course, one of the interesting elements in the supply chain is that, well, in the supply chain, because it's the real world and the physical objects, you always have certain kind of black spots. So we've had at the booth a number of people who came and asked questions, well, what if somebody, you know, you're tracking medicine, for example, where temperature matters, and somebody puts an ice cube on top of your sensors or any other clever workarounds? Well, that's the interesting part, that yes, in the physical world, you always have some workarounds. However, what we have to acknowledge is that the vast majority of fraud is happening not at people putting ice cubes on sensors to fake the temperature, but rather at a massive manipulation and erasure of data, so basically replacing the truth. And this is where, of course, using a blockchain solution coupled with IoT source data can help greatly. And on this part, I will give you kind of an overview here, and I think here maybe Vlad will take over to explain you kind of how it works under the hood in terms of different physical objects interacting either through a gateway, so basically through a secure element that we have, signing the data and putting it to our blockchain, and then later on, the data itself can be used for any industrial purposes. Again, for those of you who can visit our booth, we can show you the different applications for companies that we've built on data analytics and so on, or objects can interface directly through SDKs. And the rest of Vlad can give you an overview exactly how it works in the technical sense, and we'll be more than happy to meet you at our booth, which is, as I said, at the central room, to give you more information on the business cases.
Thanks. Okay, good morning. So yeah, I'll take over just, you know, the overview, essentially Angel gave it. I think the whole point is by combining IoT and blockchain technology, we can make those supply chain much more transparent, collecting all the data in one single place and share it as required with the authorities. So just before jumping too much into the details, let's just talk about IoT itself for a second. What does that mean? So I think in the last few years, we've seen a tsunami of connected devices appearing, toothbrushes, lamps, a bunch of things that somehow talks to your phone, talks to your devices, talks to the internet for all sorts of use cases. So even though for 10 years this has been happening, there are still a few very important problems that haven't been solved today. And I think we can summarize the main challenges in the IoT as the 3 S's. So the first S is standardization. So if you look at the history of IoT for 10 years, 20 years, there's been like a bunch of protocols, each one not compatible with each other. Many of them are proprietary, are obscure, they're owned by some consortium of companies. So really, really a big mess, and there's no single standard to bind them all today in the IoT space. There are 50 of them, so it doesn't really work. The second issue, the second S, remains scalability. So when you think about the scenarios that analysts tell us in 5 years, there will be 50 billion of connected devices, where will all that data go? We're talking about terabytes of data produced every minute, every hour. So obviously current blockchain solutions do not provide a substrate to store the entirety of all that data. So how does that work? How do we fit the two together? The third S is essentially security. If you look at IoT solutions in the past, I've been a researcher in my previous life in IoT, the first question that comes up at talks about IoT is, well, what about security? And the answer is, yeah, we'll fix that later. So it's more an afterthought rather than directly building into the product, into the solution. And this status quo has led to essentially all the problems you see today where fridges are being used as a proxy for hackers to do all sorts of bad things. So those are the main problems that even today haven't really been solved in the IoT, and the rest of my presentation is I'll try to show how our solution, how combining blockchain can help solve all those 3 problems. So the first observation is essentially that blockchain is really interesting for IoT because IoT came from a very hardware world, very, very old school industrial engineering back in the days. It has moved more and more towards more modern protocols and such, but it's still a very, very old field in a certain way, just that it was used in very close proprietary environments. And now when you look at everything happening around blockchain, which comes, which is really about larger systems, a bunch more interoperability, a bunch more decentralization, that's a very interesting trend that the IoT can benefit a lot. So really the simplest summary of what we're doing is we try to make IoT and blockchain work together at scale. So the simplest definition of our technology is essentially a middleware to integrate applications, sensor, make all of that data work much more seamlessly together, but also by supporting private and public data, because as Angela explained, some companies don't want to share some of that data, others do want to be extremely transparent. We also have been developing a universal data model, a higher level abstraction than blockchains, because in blockchain it's strongly, essentially smart contract calls, transactions, and wallets. Here in the IoT space, we're looking at a level above and really focus on the data. How do you describe a data stream from a sensor, from a smoke detector, from an alarm? How do you describe all of that in a very universal, standardized way? One of the key elements we wanted to look as well is how can we fix the cost of using the system in US dollars? Because if you depend on the volatility of token prices, any company trying to use such a system, if they don't have the ability to understand how much it's going to cost them, they're very unlikely to use it. Obviously, everything we do is open source, and especially to make all that work in a decentralized way, we've been spending a lot of time on the crypto economics. So that's the stack Angel has presented before. Core blockchain at the center, really to coordinate everything happening. On top of that, we have a distributed storage layer, which is where we can store a lot more data. This is how we can scale with the quantity of data we want to store. The third level is really all those APIs, the gateways. How do you connect more traditional devices or enterprise systems back to the blockchain? What's the proxy, the interface, if you want? And on top of that, the various apps. So let's look a little bit more closely at the three S's. So the first S is, as I mentioned, the standard. So if you are, I don't know, you own a hotel and you want to connect the different things in your building, air conditioning, the heating, lights, security, doors, if you want to create a dashboard that integrates all that data, or like a command center for your building, you have to learn a bunch of very, very obscure protocols that very few people actually know. How many in the room know an ocean? How many? Good, nice. And how many can program with an ocean? No more hands. Well, sorry. The point I'm trying to make is there are hundreds of very, very obscure things that are very difficult to learn, and the audience for people who can use that is very, very limited. So our solution, we've been working for many years on that, is what we call the web of things. Is instead of trying to look closely at all those low-level standards and learn all of them and try to integrate many to many, which becomes a really, really hardcore mess, we try to move the abstraction and the programmability layer a little bit above by using web standards, web technologies such as HTTP, REST APIs, JSON, all those really nice things that have been used on the web, and try to address and make everything, your lamp, your door, everything that is electronic in a way controllable via REST API. So this makes a lot of sense because first, you leverage all these technologies, all those solutions we've been exploring for almost 30 years now, caching, web authentication, which isn't necessarily always the best, but you can leverage all of that. You don't have to reinvent the wheel and reinvent all those things in every new protocol. And besides, I mean, TCP/IP, Wi-Fi routers, all of that you can take it for granted in most situations. And that's really important to leverage that. The second very important argument is that HTTP itself as a protocol, it was really designed for building large-scale, decentralized, ad hoc systems. So, you know, when you go to a website, you don't need to install a driver to talk to that website. So, in the same way, when you want to talk to any sort of device, it should be as easy as sending a request to that device without necessarily installing a specific driver for that device, simply understanding what commands it provides you. And the third obvious reason is to integrate all those devices, to extend the web we have today and integrate real-world data directly, natively. So you can directly take a JavaScript, you know, you can just use JavaScript to turn on the lights and do all those things. That will make it a lot more interesting. And the reason is that web stack, web technologies is a lot easier to learn for people. So you have hundreds of millions of people who can write basic JavaScript, obviously more advanced as well, but very, very few who can learn and who are interested in learning all those more obscure languages. So all of that turned into what we call the Web of Things model. So that was a W3C submission we did a few years back, where we tried to propose a very universal model for defining, in JSON obviously, for defining an API, a universal way to define what your device has as capabilities, what is the data streams it has, it supports, and how to interact with the device without necessarily knowing in advance what the device is. Really try to standardize that. That's something we've used directly into Ambrosis as well in our API. So this data model essentially means transforming, modeling everything you want, everything that's a physical object, into assets and events. An asset, as Angel mentioned, is essentially a crypto-secure, globally unique identifier for a product. You can think of it like a folder with a very long string that is dedicated to that product or to that physical object. And then all the data you want to attach to that. Here, for example, you have a transportation bag that you want to carry some vaccines in it. So in this case, you might want to put a sensor in it. It has a unique asset, so it's bag number 73, and all the data you want to record about that bag will be done through events. So events is simply a timestamp information that is persisted on chain, and the proof of that and all the metadata around that event is going to be persisted, not necessarily the data itself. You can decide for an event, every single event, you can decide, is that public data, or is that private data, or is that data I want to share only with some trusted partners. And the whole point is to standardize how do you define, how do you describe the data itself in a almost schemaless JSON model to make it very, very easy to integrate across applications. So the scalability part, how do we work, how that can scale at large, is we built what we call the Hermes. The Hermes is essentially a REST proxy that you can connect via traditional REST APIs. Very, very simple, that any web developer can start reading, sending data to those gateways. And what the gateways do is they take a bunch of sensor reading, package the metadata of all those readings, sensor reading or anything, into what we call a bundle, and the bundle gets uploaded and stored on the chain, so that if someone wants to prove you the validity of one specific sensor reading, whether this door was open at 4:43 yesterday or not, then I can give you the data, and you can always validate every single sensor entry or data entry using the blockchain. So that's really the idea. You can think of it like infra. So what infra has done is to make the development of blockchain application a lot easier by introducing REST proxies and therefore enabling a much bigger community of people to start building apps. So this is, in a way, you can think of it like that. So when you scale that, the idea is we run some of those Hermeses, but the code, the application itself is entirely open source. Anyone can download and run its own Hermes node. And a Hermes node is like a mini IoT cloud that anyone can run in their private data center, on Heroku, wherever they want to run it. And they can scale it, they can use any type of storage they want. And the main functionality is getting data as assets and events in, package all of that, and put that in what we call bundles. And the upload fee for a bundle is always fixed in US dollars. So you pay that, you pay for the upload fee using the Amber token. So that means if the price of the token goes up, then you need less and less proportionally tokens to write, and vice versa, obviously. So the interesting thing is you have the second, the Apollo is essentially the core blockchain layer, which coordinates via smart contracts all the uploads, all the proofs, everything around the upload and managing of those bundles. And then you have a second network of Atlas, which kind of works like IPFS, which is a decentralized storage for bundles. So every time a Hermes wants to upload a bundle, it goes to the network, says here is a bundle, and then you have different atlases applying to get and store that bundle and get paid over time for storing of that bundle. And the interesting aspect is that introduces first redundancies, so the same bundle is stored on several places but not on all of them, and more interestingly, every atlas can watch each other, and if one is trying to modify the data, all the other will see and he will be punished. So this creates a very, very interesting system. So even if all the atlases were to work together and try to compromise the data, the proof of the data will remain on the blockchain nevertheless. So even that will be a situation where you can realize there's been fraud. The third aspect is really security. So if you look at IoT today, 99.9% of IoT stuff today in the world, be it commercial, industrial, uses, if they're good, encryption at best and some basic forms of authentication. Very, very few, almost none to our knowledge, use hardware signing on the sensor. So do you have a sensor here? Oh, it's on display. So you can come at the booth and we can show you. But basically, we build this small sensor you can see here, very small, battery powered, using Bluetooth, and it has a crypto chip on it. So it works kind of like a hardware wallet. So every single sensor reading from this device is going to be signed in hardware by the private key, which only exists on the device. So even if the data is captured from the device with the mobile phone, you don't necessarily need to trust the phone because you will still have the ability to prove end-to-end that data really came from a sensor and not something in between. And when you use many other solutions, not having signing of the data at the source creates a big room for tampering data somewhere along the transportation line of that data. So, you know, just to summarize, I think the point is building blockchain, building IoT apps is hard, especially when you try to combine the two together. You have lots of basic problems you need to fix every time you want to build an app, from data storage, managing identities of people, of devices, integrating those different systems, processing all that data, describing different data, and integrating all of that together. So really, if you want to build global, this vision of a global IoT system, you want to solve the interoperability problem to make it much, much easier to integrate. We build really a developer-first platform with a bunch of tools, a bunch of SDKs to make the development of those apps a lot faster, a lot easier, so you don't need to reinvent the wheel. We have web SDKs, native SDKs, and to get started, you can use a Hermes as a SaaS, because what we've seen talking with many clients and partners is that the first challenge they have is to understand what's the value of blockchain first, let alone the development of the app. So they're still trying to figure out, why do I need blockchain? How can it bring value to me? So our key goal here was to make it as cheap, as fast, as easy as possible for someone to build together a prototype. And one way to do that is, here's a SaaS, you only focus on the app and on the data, don't worry about the blockchain and all that stuff, because you can do that later. So once they've built a prototype and they understand and they very quickly can iterate on that prototype, then they can see, okay, this is really interesting, now I want to scale, so they can download the Hermes node, run it themselves, but this is usually step 2, where they introduce this much more decentralized way of storing data. So yeah, so that's my last slide. So I think the main point is just centralized IoT clouds as you see today. They just won't scale when you talk 50 billion devices and all the data they need. And the best way to make that work is a combination of one public blockchain to be used as kind of ground truth between a bunch of private data stores or semi-private data stores. So scalability is a lot easier to achieve in that space, and also to get a lot more performance that you need. The integrating will be a very, very key enabler, the integration of data and interoperability and that. Blockchain security and all the private key signature and all the security practices, they should become the new standard for IoT devices, which is definitely not the case yet, but that will be a massive change. To make that work, you want to have a really good crypto economic system. And finally, it really comes down to having a very good set of tools that are packaged together that you can just start building. So we invite you to do so. Come check our stand. Feel free to reach out. We'll be here for the rest of the day for sure. And thanks. And also at 6:30, another meetup.
Yeah, at 6:30 there is at the side events for those of you who are interested. We're also going to have a meeting in French, but I guess it'll be similar content. So, but in case any of your friends miss this, 6